In Chapter 2, we've been working a lot on working with certain types of data with slope and with points of the line and the intercept. And we're going to put that together and solve some story problems today. The three story problems are as follows. Write a function to model these equations. Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises 50 feet per minute. Let E represent the elevation and T represent time. We're going to make an equation out of this, and the equation is going to be an input-output equation, and we're always going to have an equal sign with an equation. On one side we're going to get the output of elevation, on the other side we're going to get time. Now we're going to have to do something with time to figure out what the elevation is. And what we need to do is we need to always add 12 to the time, or basically add 12 to the time. So at 0 seconds we add 12 and we're at 12 feet. At 1 second we add 12, we're at 12 feet. But we also rise 50 feet per 1 minute. So we're going to take whatever the time is and multiply it by 50. So the time's 50, or the time is 1, we multiply by 50, and then we add 12, and it's 62. And then if we have the time 2, we multiply 50 by 2, and you add 12, and that's 72. I'm sorry, 112. So that would be our input-output function. For the next one, we have a little bit of different information. The candle is 6 inches tall after burning for 1 hour. After 3 hours, it is 5 1/2 inches tall. Now h is a variable that's chosen and t is a variable that's chosen. H is height of candles, t is time. In order to figure out this one, we need to find the slope first. We have inputs and pieces of information, but we don't have the y-intercept, we don't have the slope. Okay, so we need to find both of these pieces of information. So we're going to use our formula y2 minus y1 over x2 minus x1. That would be, here's our x1, here's our y1, here's our x2, and here's our y2. So we're going to take 5 1/2, and we're going to subtract 6. We're going to put that over 3, subtracting 1. 5.5 minus 6 is negative 0.5. 3 minus 1 is 2. Half of 2 is 1/4. So that's our slope. Now to find our y-intercept, we need to use one of those 2 points, and I'm going to go 1 and 6 and plug them into slope-intercept form. So it's going to be as follows. 6 equals m x plus b. And then we simplify for b. Negative 1/4 times 1 is negative 1/4. So 6 equals negative 1/4 plus b. Add 1/4. Add 1/4. And we have our y-intercept is 6 1/4. So the final equation is y equals negative 1/4 x plus 6 1/4. Finally, for the last one, we also have 2 sets of points. We have 90 students with A on the 3rd week and 120 students the 8th week. So our points are 3, 90, and 8, 120. So using our slope formula, it's going to be 120 minus 90 over 8 over 3, minus 3. 120 minus 90 is 30, 8 minus 3 is 5, 30 over 5 is 6. If we plug one of these points into our slope-intercept form, it's going to be 90, I'll choose the top one, equals 6 times 3 plus b. Multiply them together, it's 18. We're going to subtract 18 from both sides. 90 minus 18 is 72. So our y-intercept is 72. Finally, this last equation, when we put it all together, is 6x plus 72. Now, to keep track of things, I'm going to go ahead and put these down on Microsoft Paint real quick. And there's our 3 equations. And in fact, I shouldn't have had y and x in this one because I told myself that h and t are going to be the variables. So this should be h, and this should be t. So we'll keep track of that as we go on from now on. Okay. So the question then is, how many feet above sea level will the hot air balloon be after 8 minutes and 20 seconds? 8 minutes and 20 seconds is actually going to be 8 1/3 because 20 seconds is 1/3 of a minute. How tall was the candle after 14 hours? The question is, if t is 14, and this is also t is being 14. And then how many students had an A in Mr. Seal's class on the 4th week of school? So in this case, x is 4. When we go back to our equations, we're going to plug in 8 1/3 here, we're going to plug in 14 here, and we're going to plug in 4 here. Okay, so when we plug it in, it's going to be 50 times 8 1/3 plus 12. This one's going to be negative 1/4 times 14 plus 6. And this one's going to be 76 times 4 plus 72. It should be 6. Okay, so your job now is going to be to figure out what these values are when you plug in the inputs. Find out the outputs. Okay, let's change it up a little bit. Now we're going to be looking at different types of problems using the same formulas. Okay, there's our 3 equations. Now it's asking how long will it take the hot air balloon to reach a mile. In this case, what we're saying is we know how high we are, so we're going to put 5,280 feet, which is a mile, equals 50 t plus 12. And this one, there's 2 questions. How long will it take for the candle to burn out when it was lit? So we want to know when the height is 0. What's that going to be? And how tall must the candle be to at least last 1 week without going out? The last one is, if Mr. Seals had 200 kids in class, with A's, I should say, how many weeks would it take for them to receive A's? So in this case, we're going to say 200 is the input, and we're going to solve for x there. So go ahead and solve these 3 equations to figure out your answer.